QuestaSim is actually licensed, so you can use EDA Playground. If you have QuestaSim, then no problem. Yeah, I've started recording. So today let's see this array manipulations and how to code this. So I will start with my module. I will name is test, and I will declare a variable a of int type with 10 locations. So this is an array, and I haven't discussed about queues in system Verilog, but I am using it now. Why I am using the queues also I will tell it now. We will discuss about queues in upcoming sessions. So for representing a queue in system Verilog, this is a symbol to represent a queue. If we keep the dollar symbol, then it is a queue. So I will mention it here. It is a queue. I will tell why I am using a queue, and I will declare another variable, but I will comment it into C array. I will declare an array also, but I am commenting it for now, and I will declare one more variable called int out. This is also a queue. So queue is represented like this. Don't worry, we will discuss in our upcoming sessions about this queue. So basic definition of queue is nothing but the data will be stored like it is like a so in a queue we can keep on,
Like in first,
yeah, like in a first in first out like type. Queue is like that, and the location, the number of locations depends on how many datas we, it will, the number of locations will go on increasing when we insert the data. So we'll discuss it. So this is the basic intro of that queue. So uh, yesterday I have told, if I, so A is an array, right, of 10 locations, and if I want to insert some, if I want to fill the locations with some data, then one method is this concatenation method. So using this method, I can fill the array 3, 4, 6, 5, 7, 10, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So using this method, I can fill the data into this array. So this is the first method. So in this method, what's happening is all the so right side, this is a concatenation operator. So basically, what happens is this all data will be combined and it will be stored into each location in this array. So this is one method of filling the data into this array, and other method is using a for loop. So using a for loop, we can fill the data into the array. Like in C, we know, right? So we can use a for loop for I is equal to 0. Here int I is equal to 0, I less than 11, I plus plus a of I is equal to the data. I'll keep I, so that when I is equal to 0, a of 0 is equal to 0, a of 1 is equal to 1, a of 2 is equal to 2. Like that, the data will be stored into this array. So this is one method of filling the array. So instead of this method, what I am doing is I am using this operator with the help of this curly. Wait a minute, let me erase this. So by using this method, I am filling all the elements at a time into this array. So this is mostly used method. So in this method, what happens is, wait a minute. First, let me display the value of a. Then I will discuss another case. So dollar display, I will display the array. The value of array is percentage. So for displaying the array, I will use percentage p. So for displaying the arrays, we will use the argument p followed by a. So this is one way of displaying the arrays. and another method is using a for loop. So for int I is equal to 0, I less than 11, I plus plus begin dollar display the value of array is percentage d comma a of I, and ending this for loop. So this is one way of displaying the array. So these are the two ways to display an array. So first way is simply mentioning the argument percentage p, so it will print the whole array, or else we can use a for loop. So these two methods are clear, right? Is there any doubt? Yesterday we have displayed the arrays using the for loop. So this is clear, right? We can go further.
Why you are taking percentage p?
Yeah, for printing the arrays, we will use percentage p in system Verilog. So it will display in one line. I will show the output.
Okay.
So generally we will use percentage p here. So I have commented this. Let me run this. Sorry, yeah, you are correct. 0 less than I less than 10, not 11. Wait a minute, I am getting some error here. Let's see what is. So, I missed this semicolon. That's why. Compile selected. Yes, it's got compiled. Let us simulate and check the output. Start simulation. Work test. Okay. So let's see what we are getting. The value of a. Yeah. Forgotten to run this. So after running this, so you can see this array values, right? So the value of array is being printed 1, 2, 3, 4, 6, 5, 7, 10, 9, 11. So this is clear, right? Please respond, guys.
Yes, yes, clear.
Yeah. So I will end this simulation. So what if I will take another scenario here. So this is how I'm getting this array, and if I take here percentage d, then it will not print the array. Then I should use this for loop for printing the array. So this is the another uh, method for printing this array. So now wait a minute. Or else I can use for each loop. So I will show the syntax for each loop also for printing the arrays. So for printing the arrays, we can use for each loop. So for each loop, for each loop, we will give a of I. So if we use for each loop, this for each loop will assign the values of I. It will start from 0, and it will automatically consider the size of the array. That is, it will start from 0 to 10. So it will iterate from 0 to 10. No need to write like for loop. So for I is equal to 0, I less than 9, I plus plus, sorry, I less than 10, I plus plus, like that. We no need to write the whole thing. So if we write a for each loop, then it will automatically iterate the process. This is clear, right? So in system Verilog, we can use this for each loop. We can display a is equal to percentage p comma, sorry, a is equal to percentage, I will use d comma a of I. Saving this. I will compile this. So about for each loop, is it clear, right? Is there any doubt?
No.
Yeah. And then this. Yeah, after pressing this run button, then you will get this. And see, if I am using percentage %d, then I'm getting all zeros. So I should end this simulation again. And I will use this percentage %p, comma. I'm not getting this with the help of for each loop also. Okay. Wait a minute, I have commented this, that's why I'm not getting any values. I will use percentage %d only. That's why, yeah. I have commented that line, so that's why no value is being stored in that array. So that's why nothing is displayed at the output. Wait a minute, let me compile it again. And let me simulate it. Error. Error. Wait a minute. Simulate it again. If you have any doubts, ask me, guys. Wait a minute. So if I'm using percentage %d, I'm not getting it. So I will use percentage %p only. And I will compile it again and simulate it. Yeah. So if I'm using percentage %d, I'm not getting it. But if I use percentage %p for displaying, then I'm my simulation is working. And I will press run all, and let's see in the transcript. So here we can see I'm getting the array values for 5 times if I use for each loop. So this is the displaying method, and let's see some array operations. So is this clear, right? Do you have any doubt in this, guys? Is this clear, right? I'll comment this.
Yeah, clear.
Uh, Hello,
Yeah.
Gaurav. If we use, I guess, begin and statement uh, after a for each loop and keeping %d, I guess, then it will work.
Okay. Let us try it.
Argument inside for each. A of I is missing.
Yeah, given. Right? Oh, sorry. Yeah, yeah. It is simulated. Yeah. Thank you. It's working. So within for each loop, we should use beginning. On the transcript, let's see. Yeah, yeah. Thank you, Mayank. You are getting it. So,
Yeah, yeah, got it.
so if we use percentage p, then it will display in a one line. But if as we are using percentage d, we are getting uh, a single value every time. So if we use percentage p, we will get the display like this. Yeah, thank you, Mayank. So let us see some basic operations on this arrays. So first we will uncomment this C. Sorry, I will uncomment this C and I will comment this Q, and I will store. Wait a minute. So C is equal to A dot find underscore first with item greater than 2. So basically, this is saying that so find underscore first is a built-in function in system Verilog. So this is an array function. So find underscore first will find the number. Uh, Here we can mention any number. So it will find the first number which is greater than 2. So in our array, it will find the first number. So 3 is our first number which is greater than 2. So this will return, simulator will return the value of 3. So find underscore first. So this is a syntax for finding the number which is greater than 2. That is the first number. So 3 is the first number which is greater than 2. So for finding it, we will use the syntax array name dot find underscore first with item greater than 2. So this item is also a built-in variable or keyword in the in this array built-in function. So item is also a built-in keyword. So if we haven't declared also, no problem, it will simulate. So the simulation output should be 3, because 3 is the first item which is greater than 2. So let's see what we are getting. And here the C is also an array of uh, 10 locations, or else we can also take int C. Let's consider, let's see what happens if we take int C and int C of 10. Let me simulate it again. Stop getting compiled. Yeah. Here we will get an compilation error. See, array 29 cannot assign an unpacked type to a packed type int. So we haven't discussed packed type, but int is a packed type, and we are trying to assign an unpacked type to a packed type. So here int c is a packed type. We haven't discussed about packed type. We will discuss about it in our future sessions. But for now, remember this, that int is a packed type. and we are trying to assign this a of 10, which is an unpacked type. So unpacked type cannot be assigned to a packed type. Here we are trying to assign the right hand side, which is a dot. The result will be a unpacked type, and we are trying to assign it to a unpacked type. So if we declare int c of 10 also, sorry, if we declare int c, then it is a packed type. So this will not work. So what happens if we declare an unpacked type, that is int c of some 1 or int c of 2. I will take 1 and see what's happening. Now also we are getting error saying, oh, sorry, this is a different error. Sorry, I haven't commented this. Compile selected. Yeah, wait a minute. So we are getting, we are able to store the value of first underscore, wait a minute, we can store the right hand value to the left hand side, because this is also an unpacked type. So we can assign an unpacked type to an unpacked type. So this is clear, right? This is clear, right? Can anyone respond? Hello? If you have any doubt, please ask, guys.
Like, what is packed type and unpacked type?
Yeah, unpacked type we have discussed in our previous sessions, right? Like in an unpacked type, uh,
Okay.
each each digit will have separate locations. Like it will be in vertical. Wait a minute. I have to connect my writing pad. Uh, you have watched the previous video about unpacked type.
Yes, yes. Okay, okay. So unpacked type would be like a stack, one over other.
Yeah, yeah, yes. And packed type we will discuss.
Oh,
Like packed type in it will be in a same row. So unpacked cannot be assigned to an packed type. So that's why we were getting that error. Is this clear?
okay, okay, great.
Yeah. Uh, I will
Yes, yes.
I will consider one more scenario, like int c of 2, and let's see what happening here. Previously I would declared int c of 1. Now I will declare int c of 2. Let's see what's happening. I'm getting compiled. Okay. I will take int c of 4. What I'm expecting is not happening. Okay. Okay, I'm getting compiled. So let's simulate it and see. Okay. So we are getting the simulation. No problem. Where is the transcript? Yeah. So I haven't displayed it. So I'm not getting any display. Wait a minute. Let me end the simulation. I will display this value also. So I will display the value of C is percentage P, comma C. So for displaying arrays, we will use percentage P. So remember this and save this. We can also use a queue, and we can also use a unpacked type, but we cannot use a packed type like int. So we'll compile this. It's compiling. Submit it. So today's session may be lengthy, so be patient and try to attend. Sorry, I haven't run it. See, fatal error, assignment of one elements to array of four. See, this is what I was expecting. So here what we are doing is I have declared an array of four locations, but I'm assigning a dot find underscore first with item greater than 2. Then this result will be only 3. So there will be only one item. So we are trying to store one item in in an array of four locations. So only one locations will be occupied and remaining three locations will be empty. So we will get a fatal assignment error saying that assignment of one elements to array of length 4. So this, like this we will get an error if we use this unpacked type with more locations. Here if we are using int c of 1, since there is only one locations, since there is only one location and we are getting only one element at the right hand side, so one element will be stored in the left hand side. So if we know that our output will be only one element, then we can use c of 1 if we declare like, or we can use any other location c of 0 if we want to store it in any location. Wait a minute, let me end the simulation. This point is clear, right? At the right hand side, we are getting only one element and we are trying to store it in an array of four locations. So we are getting error. So instead of that, we can store it in only one location. But here also I'm getting error. If I'm trying to (31), but like this also I cannot store it in because this will become a packed type. So this like this if I want to store, then it is not getting stored. I'm getting an error saying cannot assign. Wait a minute, let me log with this. Cannot assign an unpacked type to a packed type int. This is I think previous error. Sorry. So if I want to try it to store in only one location also, I'm getting errors. Compile, selected. Yeah, I cannot store in a single location also like this. I cannot specify c of 1 is equal to, I cannot assign c of 1 is equal to a dot find underscore first because I'm getting here only one item. I cannot either use c is equal to, or else I should mention the size of the array to 1 because I'm getting only one element, or else I can use a q here, int c of q. So the according to the elements we are storing into that queue, the size of the queue will be varied. So here only one element will be generated and it will be stored, so the size of the queue will be 1. So let us run it again and see whether we are getting it. See, it's running. So let us simulate it again. So this is clear, right? Any doubt? Is there any doubt here? Is this clear? Running this. C. The value of C is 3. So this is clear. RHS we are getting only one element, that is 3, and we are trying to store it in array of 4 locations, then we will get error. So that's why we are using a queue. Yeah, so this is a concept how we should be careful while coding. So this is clear. Can we move forward?
Gaurav, instead of storing it in a complete array, can't we store it like in its location, let's say zero, like C of zero,
Yeah,
and
I have tried, right? I have tried to store it in a separate location like C of 0, but it's not accepting like that.
oh, okay,
Yeah, so we'll see one more operation. So that's why I'm using a queue.
right, right.
Yeah, and there is one more syntax for this: a dot find underscore first x with x greater than 3. So here x will act as a local variable, and instead of item we can use x. So if we declare x, then x will be a local variable for this function, for this built-in function. If we can declare any variable like y or z, like that, I'm declaring x here, and wait a minute, I will come in this, and let's see what we are getting here. Let me end the simulation first. Yeah, it's getting compiled, and let's simulate it. We are getting the see. Wait a minute. I will display the value of let me end this simulation again. I think dollar display I have used it first, then I have made the assignment, so that that's why I'm not getting any output. Let's compile it again. Simulate it. Simulation. Yeah, I've used dollar display before the assignment, so that's why I'm not getting any uh, display. I've used dollar display before assigning the value, so that's why I was not getting the value. So this is about find underscore first built-in function, which gives the first value which is greater than our prescribed value. Then we have also have some more functions, like we can find any function which is greater than a particular value. So here, after some delay, like #1 delay, I'll use c is equal to a dot find. I'll use the local variable x only with x greater than 1. So this will return the elements which are greater than 1 in my array, and it will store in C. And I will display this value. Now the display the value of C is percentage P comma C. Saving this. C. So the value greater than 1, it is getting displayed here. So this is clear, right? Can we move forward? Yes. Is there any doubt? Now let's see one more last function. So within some more delay, after some more 1 nanosecond delay, there is one more function called a dot find underscore index. It will give the index value. So I want the index value of the number 4. So I will write find underscore index with, I will use a built-in keyword called item is equal to 4. So I want the index value of 4. So I will use this keyword. I will display it dollar display. The index value of 4 is percentage B. Sorry, P comma C. Since I am displaying a Q, so use this, and I will compile it again. Simulate it. And run this. So the index value of 4 is 3. So this is how this is some of the built-in functions of fixed arrays in system Verilog. So if you have any particular doubt, you can stay and ask me, or else we can end this session. Thank you.